In many facilities, AC motor controllers are used to control and protect the operation of AC motors. When a controller malfunctions, you may be the person responsible for locating the cause of the problem and making the necessary corrections. In other words, you need to know how to troubleshoot. It's also important for you to know how to properly maintain controllers so that they operate with maximum efficiency and a minimum number of problems. In this part, we'll look at typical diagrams and charts that can be used to help maintain and troubleshoot AC motor controllers. Specifically, we'll look at examples of a schematic diagram and a wiring diagram. We'll also look at two types of charts, a legend and a sequencing chart. Schematic diagrams are diagrams that use letters, lines, and symbols to identify components and show how they're connected electrically. You can use a schematic of an AC motor controller to become familiar with the controller's components and how they operate. This is a schematic diagram of a typical AC motor controller. The controller has a motor or power circuit that provides power to the motor and a control circuit that can open or close the power circuit. A power source, which is not shown, is connected to line leads labeled L1, L2, and L3. The line leads are connected to three main contacts, which are each labeled with the letter M. These main contacts are normally open. The main contacts are connected to three overload devices, which are connected to three motor leads labeled T1, T2, and T3. The motor leads are connected to the motor. A step-down transformer is also connected to the power circuit. The transformer lowers or steps down the voltage used in the power circuit to a lower value that is used to operate the control circuit. The connections to the high side of the transformer are labeled H1 and H2, and the connections to the low side of the transformer are labeled X1 and X2. The transformer is connected to a pair of fuses labeled F1 and F2, which protect the motor controller from short circuits. If a short occurs, the fuses will blow, causing opens in the control circuit. The fuses are connected to stop and start buttons and to overload contacts. The overload contacts, which are labeled OL, are normally closed. The start button has maintaining contacts, labeled M. The maintaining contacts are auxiliary contacts operated by the M coil, which is also in the control circuit. All of the contacts labeled M are operated by the M coil. On this diagram, electrical connection points are indicated by numbers. The start button and the maintaining contacts are electrically connected to the control circuit at connection points 1 and 2. And the control circuit is connected to the X2 side of the transformer through fuse F2 at connection point 3. These numbers can be used as a reference when troubleshooting a controller, as we'll see later. Pushing the start button energizes the control circuit, including the M coil. When the M coil is energized, it closes all of the M contacts and power can flow to the motor. In this example, the start button is designed to be pushed in and released. After the start button has been released, the maintaining contacts, labeled M, remain closed to maintain current flow to the M coil. If an overload occurs, the overload devices open the overload contacts. Opening these contacts opens the control circuit, which stops current flow to the M coil. When the M coil is de-energized, the M contacts open. As a result, the path for current flow to the motor is interrupted and the motor stops. In order to stop the motor during normal operation, the stop button is pushed. Pushing the stop button opens the control circuit, which stops current flow to the M coil. The de-energized M coil opens the M contacts, interrupting the path for current flow to the motor, and the motor stops. Although a schematic diagram can help you become familiar with a controller's components and how they operate, it doesn't show you where the components are physically located in the controller. To see how the components are actually arranged, you need a wiring diagram. The wiring diagram is a graphic representation of the inside of the controller that shows the electrical connections and the approximate physical locations of the controller's components. You can use the wiring diagram as a guide to locate the components in the actual controller. For example, this wiring diagram represents the same components as the schematic diagram we looked at a moment ago. The motor or power circuit is represented by the heavy lines, and the control circuit is represented by the thin lines. The box on the wiring diagram represents the controller's physical enclosure. In this example, the fuses and the step-down transformer are located outside of the controller's physical enclosure, so they do not appear on the wiring diagram. The line leads and the motor leads are labeled the same way on the wiring diagram that they are on the schematic diagram. However, on the wiring diagram, the electrical connection points are indicated by circles instead of dots. For example, the H1 side of the transformer is connected to line lead L1 here, and the H2 side of the transformer is connected to line lead L2 here. There are actually 6 sets of main contacts in this controller, so the wiring diagram represents 6 sets of contacts. In the schematic, the 6 sets of contacts were represented by symbols for only 3 sets of contacts, because sets of contacts work in pairs. The overload devices are labeled OL and are numbered 1 through 3, as are the overload contacts. The stop and start buttons for the controller are not shown on this wiring diagram because these buttons are not physically located in the cabinet that houses the controller. However, the electrical connection points for the start switch and its maintaining contacts are indicated on the diagram by the points 1 and 2. These numbers correspond to the numbers on the schematic diagram, and they can be used as a reference during troubleshooting. As on the schematic, the M coil is represented on the wiring diagram by a circle with the letter M inside of it. One side of the M coil is connected to maintaining contacts and the start button at connection point 2. Although the maintaining contacts are in the control circuit, they are represented with heavy lines. This is because, like the main contacts, they are operated by the M coil. There are 2 sets of maintaining contacts in the controller, so the wiring diagram represents both sets. The other side of the M coil is connected to the 3 overload contacts. From the overload contacts, a wire connects the control circuit to connection point 3. Connection point 3 indicates where the control circuit is connected through fuse F2 to the X2 side of the transformer. Most motor controller diagrams are accompanied by 2 types of charts, legends and sequencing charts. Legends can help you identify the symbols and abbreviations used on the diagrams. For example, this legend shows that the letter M represents the controller's main contactor, and that OL1, OL2, and OL3 represent the overload devices for phases 1, 2, and 3, respectively. Sequencing charts show the positions of a controller's components during operation. There are many different types of sequencing charts, and they may indicate the positions of contacts or of relays and contactors. Contacts are usually shown on a sequencing chart as either open or closed, and relays and contactors are shown as either energized or de-energized. For example, this is a sequencing chart for a limit switch in a motor-operated valve. The chart shows 2 sets of contacts for the limit switch and indicates the position of the valve from fully closed to fully open. The darker portion of the solid bar indicates when the contacts are closed. When the valve is fully closed, contact set 2 is open, and at all other times, as indicated by the darker portion of the bar, contact set 2 is closed. Now, this is another type of sequencing chart for the same limit switch. This chart uses the letter X instead of a solid bar to indicate when contacts are closed. On this chart, contact positions are shown for 3 stages of operation: when the valve is fully closed, when the valve is in an intermediate position, that is, neither fully closed nor fully open, and when the valve is fully open.